Okay, it's time for a quick update. Our DAC is quickly coming to an end. I'm calling this thing like a hot rod Lincoln, boy, because this is going to be a bad dude. So we got our driver in. This bad fell up for a second. You can see we mounted the driver in the bottom, right next to the radio chassis. Now that radio chassis, when we're done, all the wires are going to be tied up. Radio chassis is going to be enclosed. There's going to be a little bomb blanket built, little Jimmy hat, and we're going to put it over the driver unit right there, which also has fins coming out of the back, as well as a heat sink that it's sitting on inside. So there's actually two heat sinks there keeping that pill. That's a single 2879 we built here with the help of our buddy Tech 9. He gave us a few tips and a little bit of help, and it came out to be a nice little board. And we're getting our final RF cavity ready to go. So at this point, forgive me while I set this thing down. We don't want to break this. This is just a prop tube, but I still don't want to break it. So everything's coming into place. Let's look at the front panel. Now, we've done a buttload of changing on this radio, but managed to keep the front panel somewhat intact. All of these controls are as they're supposed to be. Off, on, and volume. Squelch. Our RF gain. Everything. Clarifier. Now, this is a 10-turn clarifier that's in here. We didn't put the counter knob on it. And what we're going to end up doing is, this is actually set on the course, but on this chassis, apparently it's pretty critical to be able to access the fine in the course. So what we're going to do is, I'm not even going to call them fine in the course, because what'll happen when I'm done rewiring these, he's going to have two 10-turn clarifiers. I needed a way to fill this hole anyway. So we were going, let's get to the face. I wanted to keep, and he wanted to keep, as much of this as intact as possible. And despite the fact that it has a Galaxy 86V chassis in it now, a frequency counter, 400, God knows how many channels, it's 6 banks of 40, so do the math. Plus 10 KZ, Roger beep. We put all that stuff in here and managed to keep, and there's going to be the 3500Z tube. What we've done so far, this is how he's going to work his power. So all this is staying intact. Our vanity plates, I've decided for the front of this to accommodate the changes, are going to be very small. The majority of the space is going to remain intact. All this bottom, we're leaving it alone. Leaving it alone. I'm going to put another, hopefully it'll fit comfortably. If it doesn't, I'm going to use one of these. But everywhere you'll notice we're using diamond cut knobs just like DAC did. These are actually Alpha 2000. You know, we do a lot of 2000. And all these need to be cleaned up. We're almost done with construction. Final construction. Everything we're doing right now is permanent. It's done. It's the last of it. So our back panel's pretty much wired, which was, geez, we had to put relay systems in to accommodate all the meter functions properly. You see part of the top of the chassis right there. And we had to make a cable, obviously, to extend the display up, which isn't like the old school ones. This display is a trip, man, and so are these digits. There ain't no change in these digits, guys. At least I don't see a way to comfortably do it. This whole frequency display, I don't have any out, or do I? No, I don't. This whole frequency display is smaller than half of a stick of gum. The entire display. I'm talking about the driver and everything. It's all, well, you can see it back here. There's the entire frequency display counter back there, okay? We took it out of the radio. Now, when this goes in the radio, it gets plugged into a switch bank, like I said in the last video, and that switch bank does some trickery to make this funky counter that they've got work. And after blowing a couple of these up, we finally figured it out. But you can't fix it. I don't see a way to take these apart and fix them. You really got to be into some surface mount, get it on small, teeny tiny, and we just ain't there. We don't do that. We're playing with stuff like this. It goes in, it works perfect. We're done. But the guys are going to be sending me these radios, and I build them with this chassis when we can get it now. That's another big thing that's going on. We're having a really hard time getting brand new radios for anything right now. So let's look at power. Well, first, let's look at meters. We had all the meters with, we got these LEDs that are actually tinted like old school bayonet lamp. Has that ambient glow instead of like a direct LED beam. However, and in the DAC, there was only one light went across here. When you put them in, and the unit's actually made to accommodate these LEDs. If you look in here, the saddles are in here. These are the light connections right here, and then you got to nice and neatly get those things in there. And I don't know who did that. Yeah, I do. I did it. And it looks pretty damn good, I think. You get them all together. Now, here's something else about these DAC meters, guys. When you put them together, clean the inside of these. See how this is lined with a white, like, trim? When you put these on, I just did it wrong in the last way I did it. You don't do it from the top. When you're putting these on, you take these up from the bottom. You pull all your wires up at the bottom of the meter, like so, see? Whoop. Pull this up, snap your top on. That's how those meters go together. Our signal meter, you can see, is working just the way it's supposed to. It does not over or under react. It actually tracks really well with what it's supposed to do. Now, there's been a few of these DACs we put together with a few of these chassis that, yes, the meters worked, okay. Accuracy, and I told those guys that have those radios, no. They weren't built to this level either, but it's important that if you've got all these meters, you try to make them work as accurately as possible. The good thing about the 86V chassis is it has the automatic calibrating SWR function. So this never has to be calibrated. This is always going to tell us what's going on. And it's kind of funky. It's not funky. It's just you have to learn how it works in this radio. Everything that you see here, we've checked against an external meter. This has been checked with our signal generator coming in, and it's within like 3 dB, where it should be everywhere. The modulation meter, as you can see, audio 1 2 2 2 2 works just fine, and our SWR meter. When you first talk, it comes up a bit. But when you go to modulating, it actually shows me exactly what my external meters show me. So there's the meter functions. Now the radio by itself, this is just the radio chassis without the driver on. It's a 100-watt slug. We are on peak. This is peak watts. It's about 55. Okay, and the dead key. We turn this mic gain down so it doesn't interfere. With everything off, the dead key is just a hair over 2 watts. Okay. Now, I only run this thing with the mic gain on 12 o'clock. It rocks. Oh, and our channels. Let's get to that. Lowest channel. We showed this in the last video. Here's all his channels. It goes from 2651 all the way plumb up to like into the 2900s if you turn it up high enough. There, 2904. So, and these are all stable, and it transmits on all of them with pretty close to even power. So that's pretty cool. So now we're going to go to our driver stage. We've got that done. It's in. It's done. It's ready to go. If I want to put the lids on it now and send it out like this, I can do it. But we're not going to do that. We got one more stage to put in, and that's that guy. However, he's going to need a way to switch between these. Now, just because we're building this radio with, you know, a 500-watt RMS tube, doesn't mean he's going to want to run it with the 500-watt RMS tube all the time. Doesn't mean he's going to necessarily want to run it with the driver on all the time. So, you know, we're going to have a function switch. Now, in the middle is just regular radio power. If he pushes it down, like we just did, it's burying 100. It turns the driver on. Okay. It turns the driver on without turning the 3500Z on. Now, I have a pre-scaler in here. So it takes a 100, 250, 500. We're going to go to the 250 scale. That's the top scale. Which means, my leg is keying the microphone. Which means right about in here is 100 watts. 150 is right there. It's PEPing about, it's PEPing 100.5 easily. Okay, and that is what we're going to drive into this tube. So now, that's the next thing. Everybody's like, first thing was how you get high voltage in there. And still in just the, you know, without making this a two-piece. Now, we are going to build another one. I am going to build another one eventually in the future. For me, we got a case for it, finally. Mine is going to be a two-piece with 2 of these in it. ergo why mine's going to have to be a two-piece. But in this one, right now, we got to solve the problems with a single tube first. So we got a transformer that's going to sit down here nice and neat. Got our doubler right here. Got our 5-volt. Now, we do run our filaments on DC, which changes how you bias this tube a bit. 45 amps of 5.1 volts is coming out of this pack. And you have to do a little buffering and trickery. Otherwise, if you drive this pack straight into these filaments like you would assume you could, it doesn't work. It's going to shut this pack into shutdown. You have to do some work there. So now our tube is in. Now we've got a very limited budget as far as real estate goes, as far as where to put these tuners. So we went and did. Now everybody thinks I'm a hoarder, but you know what? Right now, I'm the one that's laughing because we really needed this guy. Look at the shank on that coming out, how long it is. Now on this DAC, once the cover goes on, there's this much space between the edge of the radio and the chassis. This is going to be our tune, or our load. Okay, and it's going to sit right back here in the corner. Damn close to that tube for my taste, but it's going to work. Okay. And then this is our actual tune. Let me get this lollipop out of the way here. This is going to be our actual tune control. And what we're going to do is, the way the speaker was cut is perfect because the way this tuner is made is kind of funky. We're going to flip this guy upside down. All right. And it's going to go. It's going to go. Wait a minute. There we go. Boop. It's going to go just like that. So it's going to have the tune on here, sitting right here. And I do got some shank extenders to go ahead and get this out the side of the radio. But that one's going to go plumb out the side by itself. No problem. We'll be able to put a knob on it. Now, it doesn't really look like it in this picture, but by the time this one's going to get soldered in. We're going to solder this guy straight to the chassis, be done. I know this one's going to have a proper ground. Oh, this could go way farther back. There we go. That's where that one's actually going to live. Right there. It's going to get soldered down. Then this guy, that's our load. Here's our tune. Now you notice this is real old school stuff here, and it was kind of cheap. This is what cheap looked like in the old days, riveted together. But it's the perfect value for what we're trying to do. I forget what the value is. It's 0 to something. Not even 0. I think it's like 10 puffs to something. But it's like a 15,000 volt cap, air variable cap. So this is going to sit in here like this, right? We'll put the holes in the side appropriately. But that's how our tuners, there we go, now we're straight. That's how our tuners are going to sit in there. Our tank coil will just go directly across in between here. Believe it or not, there's enough room for me to get a strategically made tank to go across this mess and not arc on nothing. We are actually going to use on top of the tube, don't laugh, because it's going to work just fine. And I've got some really nice, heavy duty, going to clamp the cheese out of this thing. They're clamps for sweep tubes. Guys, just because they had all these fancy clamps on here and whatnot from Heathkit and Collins and all them guys, look, yeah, that stuff's nice and it has a purpose. You know, when you're blowing the air across, those do help draw heat out of the core. However, this tube, and when we started designing it, I called the customer immediately and told him, you know, yes, we're going to get the tube in there. And originally it was going to be a 250B, which was going to have to make this a two-piece. If you know anything about triodes and tetrodes, this is a triode. This only requires 2 voltages to run, high voltage and filament. That's it, and bias. And bias isn't even active. It's negative current being drawn through a diode pack that we make. But it is getting biased negatively, where, like in a Heathkit, at rest, when you're in receive, it throws 110 volts of DC at the filament grid, or at the filaments, and that's what's keeping it from cherrying up and receive. When you transmit on a Heathkit, it switches to a 5-volt Zener diode, and it pads that 110 volts through the 5-volt Zener diode, which gives it plus 5 volts DC for bias in the Heathkit. We don't do that. We float the filaments to ground through an added coil on the filament choke, and when we go to transmit, it pulls negative current to a diode pack we make, and it works great. But we are going to use a sweep tube clamp on this. We're going to come across through our cap right into these tuners, over with. That's going to leave me room to get a bond blanket behind all this, because we have metering and all this. Now, all this loose RF in here, you got to keep all this into account when you're putting this kind of stuff together. Once this tube goes to getting down, and I'm going to parasitic choke the bejesus out of this thing. Every pin on the bottom is going to be going through its parasitic choke. The input coming in is going to have a choke. I'm going to add one between the radio and the driver module. And there's going to be one between the driver module and this tube. Now, why am I going to mix tube-type technology with that board between the radio and the board when I'm feeding the board into the tube? Well, because the parasitics can still get in between the two devices going from the radio to the driver. So we're going to absorb all that as much as we can before everything. If you don't understand how a parasitic choke works, I don't know if I have one laying around here to show you. Probably got one in the tool cart over here. Here we go. Here are a bunch of handmade parasitic chokes. Now, this is my understanding. I'm not an engineer. Here's a perfect one. Boom. Now, what happens is all this loose RF is floating around in the air. Okay? If this were a straight piece of wire right here, it's going to allow any oscillation in the air. It's going to pick it up, and it's going to inadvertently feed it to the tube. Now, and that's when the tube begins to break into oscillation. What this does is, this resistor in the middle of this inductor, that's what this is an inductor. It's a load, it's a coil, it's a miniature tank, just like it goes across here. It's an inductor. Any current that is not directly driven into one side, any current that is directly driven into one side will pass across here, not be affected too god awful bad, come through this guy and do its job. Now, anything that's floating in the air that this may pick up that isn't directly applied will get absorbed in that resistor. In other words, the resistor will suck it up because it's so minute that it never gets in here. Resistor just eats it. It's my understanding of how this works. Now, that may be a very layman's term of how it works, but it does work. Now, what am I going to do? I'm going to put one of these in between the radio and the driver board. Even though those are both solid state units, and they're, a tube is active all the time. A transistor is not really active until you hit it with current, unless something's going on that causes it to break into oscillation. That's a whole other world in transistors. We only use transistors around here for the most part for drivers. Rarely will you see a transistor amp come out of this shop, but sometimes we do. Moose and Crete's got one of our 4 pills. Gator and Crete's about to get 6 pills. And those are probably the biggest ones I'm going to build, because I am a tube guy. We like tubes here. That's why there's a 3500Z going in here. But you got to drive it. Unfortunately, to get to that level, I got to use another transistor, and that's 2879 on the board we put in there. But back to the choke. We're going to put this device in between the radio and the driver board, just to make sure that the driver board is well tuned, but anything that comes through here can be directly driven. Anything that gets into that driver board is going to be directly driven from the radio. Anything else is going to get nulled. Okay, and that's what it does. It nulls any loose RF. That's another way to say it. So then there will be one between the driver module and the feed of the tube as well. Every connection, we're in ground and grid on this one. So all, 1, 2, 3 of those are going to not go directly to ground like we normally would. We're going to float those pins back up, and I'm going to take them to ground through one of these. Because that little bit of space on the bottom of that tube socket, from the tube socket to the chassis, it's only that long, but it's a straight piece of wire. Believe it or not, there are frequencies that run on that big of a size, get into gigahertz, and beyond that. Our wavelength is, bigger than this room. There are frequencies that literally, we're talking really fast, guys, but, that band that we take to ground is just big enough to pick something up that we don't want. So we put the sponge in. Think of it that way. It's a loose RF sponge. We're gonna take anything that can be, ambiently absorbed into the tube to make it break into oscillation. We're going to try to null it before it gets into the tube. So, and we're going to that extent because we have this big ass tube in this, what is big for a radio, but we didn't build a radio this time, guys. We built an amp with a radio in it. Just happens to, there's barely enough real estate in here to do what I'm doing with this one. I don't know that I'm going to be able to do a 2-tuber. It's going to have to be a 2. It's going to have to be a 2-piece. But anyway, this one's getting there. It's almost done. I'm getting ready to flip it up on its side again. I've been talking on it for a day. I wanted to give it 24 hours running with the driver. We have driven my old dock box with it. That's 4 572Bs and an old Mako 750Ks. And it drives, and that thing will upset even the most forgiving of radios, that little guy down there. And this radio drove it like a champ with the driver module on. It's beautiful. So we know it's going to drive power. We don't have any problems with what's here driving power at this point. But now the power's not going to be down there. It's going to be right next to everything here. So we got to take all the extra precautions. When I'm done, this will be walled off a certain amount. This will definitely be walled off all the way here and all the way here. All the way across the back and all the way across the caps. It's going to be a wall. And more than likely will come up all the way to the top of the unit. At that point, the lid will take over and keep this trapped. On the bottom, we're putting the cover back on the original cover for that mobile back on the chassis. It's not going to have a face. Everything's sticking it out. Now this is the face of the radio. So the only meter we have left to hook up is this one. And what this one's going to be is, you'll notice when we transmit before, nothing jumped except the modulation meter. Because our output power meter is not hooked up. The output power meter is going to switch automatically. Now when we're in this mode, it will show us what the radio normally does. Okay? Even with the driver on, you're still only really going to see the radio. But when we go to flip the big dude on, this meter, this basically just controls our standbys for the bigger parts of the amp. It's a 12-volt circuit. So what we're going to do is we're going to have it, when we go to high, we're going to take that 12-volt pulse from the high switching unit over to a relay that's going to switch this meter to either an ambient loose RF pickup that I'll make that will give us a nice reading, but it won't be dead accurate. Or I do have a couple of small bridges that have come out of other amps that we can do. But anyway, it will have to be switched. Otherwise, it's just going to peg if I try to meter the high current. I'm going to have to make a whole nother circuit, put this meter on a relay, and just like this, it's like this one. There's a little relay back here because these two functions are on the same wire in the radio. When you're looking at the meter in the 86V and it's receiving, and then you key, there's a switch that either makes it transmit, off, or transmit modulation combined. I think, if I remember that. But at the end of the day, this one wire did these two functions. So when we key the radio, there's a relay in here that takes that wire away, that takes that signal away from this meter and flops it over to this one, so our modulation plays. And they are independently thresholded on the board. They're two different circuits. They just happen to be bridged coming to, because in the mobile, just 1 meter. On this base, we have 4. But the radio has 3 independent functions in it, where normally I got to take like a PDC 600 if we're using like a 29 or something that's got really no extra meter functions for a straight AM or a cheap sideband that doesn't have a whole lot of meter functions on it. Then we got to take like a triple meter set, take the SWR bridge out of it, we put it in the bottom, and that runs the meters instead. It's nice on this one because we got so much in here. The 86V chassis, all the 148 troubles we had trying to build this radio with those actually ended up being a blessing, because this 86V chassis has all the proper outputs. And once we extended all the basic functions, we had them all here and had them all labeled. So now all that's done. Tube's going to be going in today. At the end of all that, we're going to make the tops getting redone in a nice, like our blue varmint was. Top's going to get redone in black matte. It'll look like the top of a brand new Galaxy. And then we're only going to make 2 very small vanity plates. One to go from here, right next to the switch, over, all the way under. And this will be relayable RF power, because that's what it is. And then this window is not going to be as big anymore. It's only going to be big enough to read the SW, or the frequency display. However, it will come all the way across and up. So it'll be this square, making me able to, and we have material that looks like this we're going to put on top of that very thin plate we're going to put on here. You're barely going to be able to notice it. But once it's on, it's going to erase these, and it's going to erase all this. Now on this side, we're going to have the same size panel coming across, stop it at the switch. However, here we're going to cut this whole window out, because when you have a 3500 of any kind, you need to be able to see the filaments or the core if you can. All right, there we can see the graphite core through there. We're going to make this a view window to the inside of the radio, as crazy as that sounds. This is going to be a view window where he can just reach down and you see the graphite right there. That graphite's cherrying up. He's got problems. In the DAC, once we've got the lid on, if I were to just blank that out or whatever, put lights in there or whatever, and he can't see the tube, that's a problem. He needs to be able to see every 3500Z amp that I've ever seen. You can peek in and at least see the glow and make sure they're not in some way or another from some angle, and make sure that the tubes aren't cherrying up. So we're giving him that. However, we're getting rid of the NBA now because that's on all the time now. This transmit standby, that's the switch now. This is gone. All this is now here. So yes, 2 small vanity plates keeping the rest of the front of the radio intact. I might do some custom lettering here, saying, I'm poking my chest out a little bit, put my name in there, a little bitty letters somewhere. Got to do it, man. I think I deserve it. This radio's been a monster. So that's where we're at now, guys. We're on the downhill slide. I don't worry about tubes. I sleep in tubes. I can do it. So we're going to get it going. And like I started to say, I called the customer. We are probably not going to get the full 500 watts of RMS out of this tube. But who cares? We're going to get as much as we can, 2300 plate volts. We ought to be able to get it pretty close. However, the lack of real estate inside my RF cavity's got me a little concerned. But there are ways to fool the tube in that manner as well. So it's all a matter of how many tricks you got up your sleeve. This one's getting in my tricks up your sleeve box pretty deep, though. Well, I'm always trying to outdo myself around here. And I started to think I bit off more than I could chew till I realized that my hoarding saved my behind on this one. However, it gives me an idea for something just a little bit bigger, which always happens. And you guys know me. I'm like a dog with a bone. This is 14 months of can it not, building it on, on breadboards and stacking equipment on the bench together to see if it was all going to work together, and mock tube cavities, and 14 months of engineering loosely to try to get this thing in a DAC 10 case in one box for this guy. I don't care if mine's a 2-piece. And honestly, this gentleman didn't care either. We were almost going to do it. But Hot Rod Lincoln's going to be intact. All one piece. It's all going to be in this box. Man, grab by the handles and go. Not have to carry an extra piece. Not have to have a cinch plug or none of that stuff. So, which is not bad. Don't get me wrong. If you've got a proper cinch plug, you can do a lot of stuff externally, and that's great. But make sure you got a proper cinch plug, and make sure the cable that's carrying whatever current going back and forth is suitable. In the meantime, I got a tube to wire up, guys. 7 3s 0409. We'll see you.